So lesson number 6 is problem solving. So instead of being given the triangle, we might be given circumstances in which we have to draw the triangle, or we're given a sketch of a triangle, but it gives us some application as to when would we use trig to solve in real life situations. So Carmen is a surveyor who uses a transit. A transit is those little tripods with the little boxes on them that you see surveyors using when they're getting ready to do work, construction, or moving land or anything like that. The transit's placed 52 meters from the base of the tree, and the angle to the top of the tree is measured to be 12 degrees. So the angle to the top of the tree is measured to be 12 degrees. If the transit stands 1.8 meters high, calculate the height of the tree to the nearest tenth of a meter. So if I look at this diagram that I've drawn, my triangle is right here. Does this correspond to the height of the tree?
That plus 1.8.
Plus the 1.8. Because this, the height of the tree is only that much. I need that 1.8, which is the tripod that the transit is sitting on. This measurement here is still going to be 52 meters because these two lines are parallel to each other. So I have an angle. What is this side in relation to the angle?
Adjacent.
Adjacent, and I'm trying to find which side?
The opposite.
So which trig function do I use for my opposite and my adjacent? Tan. So my tan of my 12-degree angle is the opposite side, which I can call x or h or d, whatever letter I want to represent my unknown height to the tree, over 52. So this one is a multiplying, 52 times tan 12, and to the nearest tenth of a meter. So I would probably maybe keep this answer to 2 decimal places before I add in that 1.8. So what do you get to 2 decimal places? Okay. So I get 11.05. So then the height of the tree would be 11.05 plus the 1.8. And what does that give me? So the tree is 12.9 meters in height. Now, question B says determine the angle the base of the transit makes with the top of the tree. So that is looking the base of the transit right here to the top of the tree. So in that triangle, if I replicate that triangle down here, there's my 90 degree. It's not very drawn very right angle-ish shape. Make that better. This is still my 52 meters. This becomes my height of the tree. And here's my angle. So that's the angle I'm trying to determine. So in relation to my angle x, what do I call the other 2 sides?
Your opposite and adjacent.
Okay, and what trig function is opposite and adjacent? So tan of my unknown angle x becomes 12.9 over 52. So then it's the tan inverse. And what is my measurement? How much? 14 degrees would be correct. Who remembers circle geometry from last year? Who didn't want to have to remember circle geometry from last year.
I like circles too.
Eric, put your hand.
Hey, I can contribute.
A circle with a center of C and a radius of 20 millimeters is tangent to the arms of angle POQ. If angle POQ is 50 degrees, determine the length of O to C to the nearest millimeter. So when it says a circle with center C and a radius of 20 is tangent to the arms, these are the arms of angle POQ. What does tangent mean? Where is the tangent point?
It means they meet at the circle.
It's where the circle and the angle, the arm meet. So that's here and here. And what do I know about the line drawn from the center of the circle to the tangent? It's the radius, and what else do I know? It creates something. A line drawn from the center of the circle to the point of tangency is perpendicular, which means it is 90 degrees. So now, if I draw a line from O to C, because that's what I'm asked to calculate, what do I have right here? I have a triangle, a right triangle, and if I drew the same line down here, I would have another right triangle, which means these two triangles have to be the same, because this length here is the same, this length here is the same. I'm going to have two congruent triangles. So what can you tell me about these two angles? They're going to be the same. And the whole angle was how much? So what's each partial angle? So if I wanted to change this triangle up so that I could see it a bit better, this right here is my O to, let's just call it T. So there's O to T. O to C. Oh, I've got that written backwards. There we go. T was my 90 degree. So O to C is my hypotenuse. That's what I'm trying to calculate. Angle O was 25 degrees, and this C to T was my 20 millimeters. So what trig function would I use to calculate that hypotenuse? Sine, because sine is opposite over hypotenuse. So sine of my 25 degree angle is my 20 degrees over side OC. How do I solve for OC?
20 divided by sine 25.
This is the divided one. And somebody needs to tell me what that would be to the nearest millimeter.
Okay.
47.
How much?
47.
47 would be correct. Okay, so let's take a look at E, or sorry, 3. In many problems, the angle of elevation or depression would be determined from a person's eye level, not from the ground, but from where my eyes are. So in the diagram, the man on the ground is standing 12 feet away from the wall. The angle of elevation from his eyes to the eye level of his wife in the building is 62 degrees. If the man's eye level is 6 feet above the ground and his wife's eye level is 5.2 feet from the top of the building, determine the height of the building to the nearest tenth of a foot. So what information can I label on my building? Take a moment and take the information from the question and try to label as much of the diagram as possible. So what can I label on this diagram? What did you label, Kirsten? Give me one thing you labeled.
The bottom at 12.
So, like here would this also be 12 feet here?
Yeah.
Okay. What else can you label? Colin, what did you label?
The 6 feet that the husband is on the ground, like where the dotted line is.
So here?
Yeah.
Okay. Taylor, what did you label?
Half 150 is like at the top. Yeah, from there to the top.
Okay, is there anything else I can label? Tyrone.
The angle of elevation is 62 degrees.
So what do I need to find out?
The opposite of that. What's the opposite?
Okay, that's what I need to use, but what am I trying to find out? What am I trying to solve for?
The height of the building.
The height of the building.
So I'm trying to find this part. I'm trying to basically find the distance, the vertical distance from the husband's eyes to the wife's eyes. And you guys were telling me I would use tan. So tan what?
And 62.
62 equals.
X over 12.
So to solve this one, it's multiplication. And what do I get? To nearest 10.
22.6 feet.
So now when I go to calculate the height of the building,
You had 11.2. I just added both the heights.
so how much is that?
33.8 feet.
So the building is 8 feet.
8 feet.
Or sorry, 33.8 feet. Checking if you were listening. Of course you guys were. So the building is 33.8 feet in its height because I have to include these two pieces. So it's something to think about. We make a lot of assumptions in math, but sometimes we get questions that give us more information. Because it does stand to reason that if I'm looking up at something, the angle of elevation is between my eyes and that peak, not from the ground to that peak, unless my eyes are lower. Bearings is a way to describe direction. When we talk about a bearing, we always start due north, because a compass can always point north to me. So I start off with a bearing, I start off at north. So if I tell you that you're going on a bearing of 40 degrees, it's starting north and it's going 40 degrees clockwise. It's always clockwise. So if I say you're on a bearing of 150 degrees, that's what 150 looks like. 225, think halfway around would be 180 degrees, so then 225. So something to consider if I'm looking at bearing measurements. How many degrees would this be?
90. 180. 270.
And then all the way around would actually be 360 or 0. Okay? So then that way when I'm told a bearing of 135, I can approximate where that 135 would be. A ship travels 6 kilometers from a port P on a bearing of 120 degrees to a position Q as shown. So port P to Q, how many kilometers?
6.
And this bearing in here is 120 degrees. The ship changes direction at point Q and travels north until it reaches position R, which is due east of P. So it's due east of P. That's due east. And it's traveling north. So this becomes point R. So how far east of P is the ship at R? This is the measurement I'm trying to find. So if I know that this whole angle here is 120 degrees, could I determine what angle RPQ is? How?
Well, it's
Does it look half and half?
no, you would subtract 90 from the 120.
Why 90?
Because you're trying to find the right angle from NPR. Like you're trying to, I just hard to.
Because-
So NPR, your desk should be a 90 going
Yeah.
east. So you're subtracting that 90 to find.
Because going due east is a 90-degree bearing.
Yeah.
Okay? So then angle RPQ would be 120 minus 90, which would be 30 degrees. So the distance from Q to R, more 6 or less than 6? Less than 6 kilometers. I know that for sure. Okay? So I have an angle, I have its hypotenuse, and which side am I trying to find?
Adjacent.
Nope.
Opposite.
Opposite, because I'm trying to go from point Q to R, right? So what trig function? Sine. So sine of my 30-degree angle is the opposite side QR over 6. So this is multiplying again. And what does QR equal? Oh, sorry, you're right. It's not QR I'm trying to find. What am I trying to find?
I was confused.
I'm trying to find RP.
That's confusing.
So that would be hypotenuse and
Adjacent.
adjacent. Help if I read the question. So which one is adjacent and hypotenuse? Cos. So it should be cos of the 30-degree angle is PR over 6. So then PR would be 6 times cos 30. How many kilometers is that?
The nearest 10.
Yep.
522.
So it's basically 5.2 kilometers away from the port. Okay? If the ship continues traveling north for a further 12 kilometers to position S, so from here it travels 12 kilometers to position S, determine the bearing of S from P. So what I need to put in, I want to create a 90-degree. This is point S up here now, and this is 12 kilometers. And what I want to know is I want to know my bearing from point P. This is what I want to figure out, is this angle in here. These are two, what type of lines? Parallel line. This is a transversal. So what do I have? I have alternate interior angles. So this angle in here, NPS, would be the same as PSR. So if I calculate angle PSR, I would then be able to determine the bearing. I have this measurement already. I have the 5.2 from the previous question. So what trig function would I use with the 5.2 and the 12? Okay. angle, what do we call it? Angle PSR equals what?
5.2 divided by 12.
So then angle PSR would be the tan inverse. And what do I get?
The nearest
To the nearest degree.
23.
So then the bearing would be 23 degrees from P. So if from the port all of a sudden I had to send a ship because the ship now gives me a distress call, I would tell my ship to go on a bearing of 23 degrees from the port. And that would bring me to S. The ship has a speed of 9 kilometers per hour throughout the journey. How long will it take for the ship to go from point P, the port, to Q, to S? What do I need to know?
How many kilometers they traveled?
Okay? Do I know how many kilometers they traveled yet?
Just add it up together.
6, 12.
How much Q to R is it?
So how do I find Q to R?
We did.
We started to find it.
Yeah.
So that's my sine. Sine 30 is QR over
6.
6. So then QR would equal 6 times sine 30, which is how much?
3, wasn't it? There's 3, wasn't it?
Was it exactly 3 or 3.0?
3.
Yeah, because sine 30 is 1/2.
Yeah, it's 3.
So now I have the total journey. (12 plus 3 plus 6 is how much? 21 kilometers. And I'm traveling 9 kilometers an hour. So how do I figure out time?
Divide by 9.
Divide by 9. What do you get?
2.3 repeating.
So 2.3 repeating means 2 hours and 20 minutes. Or a third of an hour. Questions will be none.
Try.
Thanks, Chuck.
It's failed the first time.
1, 3, 4, and then 7, 8, 9.